See, you know what is relation? Now we will discuss types of relation. The first type of relation is reflexive relation. What is relation? You know what is relation? A pair of xy such that x belongs to A and y belongs to B. Right? What is reflexive relation? Reflexive relation means both elements are of same, right? This is called reflexive relation. Those pair which are same, which exist same value, they are reflexive. You can also say x related with x. Okay. For example, 1 comma 1, 2 comma 2, 3 comma 3 are reflexive relation. Understood? Symmetric relation. What is symmetric relation? If x comma, yes, yes. For example, if 2 comma 3 is there, then 3 comma 2 must be there, right? Third one is transitive relation. What is transitive relation? X comma y related yz, then x comma z must be there. Okay. Yes. If these relation comes together, they are called equivalence relation. Okay. Yes. If these relation comes together, they are called equivalence relation. Understood? Yes. Note this. Noted? Done? Okay. The next is antisymmetric. What is antisymmetric? If x comma y belongs to R, You can also write A, B. Okay. If A comma B is there and B comma A is there, then A must be equal to 2. Or if A comma B belongs, then B does not related with R. Okay. Either you have what? A comma B, B comma A. Then A is equal to B. Either these pair, or if only A comma B is there and B comma A is not there, then this is what? Antisymmetric. Understood? See, if A comma B is there and also B comma is there, then A must be equal to B. A or B must also be there. Okay. If only A comma B is there, then B comma A must not be there. Understood? Yes. If any one of these pair comes in relation, then you can say antisymmetric relation. Here, A is equal to B, check only when B comma A is there. Okay. A is equal to B, check only. Okay. A comma. mm, okay. See, 3 is equal to 5. This is not true. See, only 3 comma 5 is there. This is antisymmetric. But if 3 comma 5, can you say 5 comma sorry. Can you write this? This is false, right? So 3 is equal to 5 is only true when, right? When both are same number. Understood? Yes. So this is true only when A and B are same. Otherwise, you can write only this. For example, if A divides B, 2 divides 4. This is true. But 4 divides 2. This is false. When both, yes, when both true, when 2 divides 2, right? Yes. So this is antisymmetric. Yes. 2 divides 2. 2, no, no, antisymmetric. A is equal to B when both number, when 4 becomes 2, right? So you can say this is antisymmetric. So antisymmetric means when opposite direction are not allowed. Opposite means if 1, 2 is there, then 2, 1 cannot be there. Okay. It is allowed only when, except when both are same element. Understood? If both are same element, then you can say, okay. Yes. One more example you can see. A is friend of B. B is friend of A. When both true, yes. When A is equal to B, right? But yes, this is anti-symmetric, right? No, no, this is symmetric actually, not anti-symmetric, right? No? Not anti-symmetric. Because here it is not necessary that A is equal to B, right? Not anti-symmetric. Here I wrote opposite direction are not allowed. Opposite direction are allowed only when both are same element. Noted? How many elements are there? 4. So for reflexive, you must have what? Given relation is what? But in this relation, you, yes, you have not 1 comma 1, right? So this is not reflexive. It is reflexive only when this set contains also 1 1, 2 2, 3 3, M 4 4, right? But 2 2 is already there, so you can exclude this. Understood? This is symmetric. 2 3 3 2 is there. 2 4. This is not symmetric because 2 comma 4 belongs to R, but 4 comma 2 does not belongs to R. Understood? Check transitivity. 2 comma 3 belongs to R. 3 comma 2 belongs to R. So 2 comma 2 must be there. Also check 3 comma 2 belongs to R, and 2 comma 3 belongs to R. So this must contains what? 3 comma 3. But 3 comma 3 does not belongs to R. Right? You can also check what? 3 comma 2 and to any pair. If any pair dissatisfied the condition, then you can say not transitive. Okay. Check whether this is antisymmetric. 2, 3. So you cannot say 2 is equal to 3. This is not antisymmetric, right? Yes. Equivalence? No, this is not equivalence because this is neither reflexive nor symmetric nor transitive. Understood? Yes. Tell me. 1, 2, 3. 1, 1. 1, 1 is not there. So this is not reflexive. 1, 3, 1, 2. 1, 2, 2, 1 is there. 1, 3, 3, 1 is there. 2, 3, 3, 2 is there. So this is what? Symmetric. Right? Transitive. 1, 2, 2, 1. This is not transitive. Why? Because 1 is related with 2. 2 is related with 1. So 1 must be related to 1. But 1, 1 is not there. So this is not transitive. If any one of them out of 3 is not hold, so you can say this is not equivalence, right? 1 comma 2 is there and 2 comma 1 is there, but 1 is not equal to 2, not antisymmetric, right? Can we move? Tell this. Done. Now see, A is the set of all students in university. X is taller than Y. Understood? So X is taller than Y. you can say x is greater than y. If x is greater than y, then you cannot say x is greater than x. Is it true? Not possible. If this is not possible, then this is not reflexive, right? If x is greater than y, then y is greater than x. This is also not possible because let's suppose x is 5.4 feet and y is 5.2 feet. Then you cannot say 5.2 is greater than 5.4. This is not symmetric, right? Yes, you understood this. X and Y are born on same day. Same day, let's suppose Monday. Yes. It is reflexive, yes, because first and second both are born on Monday. This is also what? Symmetric, but not antisymmetric. Sorry, also antisymmetric. Yes. No, no, that is different question, right? This is equivalence relation. And this is also what? Transitive, right? This is reflexive and antisymmetric, right? This is not reflexive. Why? Because 2 is not there. This is reflexive but not antisymmetric. Why? Because 2 comma 3, 3 comma 2 is there. 2 cannot be equal to 3. This is not reflexive, not antisymmetric, right? Not reflective and antisymmetric. Okay? Yes. Composition of relation. This is relation R and this is relation S. So how will you write? First check R, sorry, inside S. 1 is related with 3. Now check 3 is related with 1. So you will get what? 1 comma 1. हमेशा अंदर वाला पहले देखेंगे. So you will check what? 1 is related with 3. Now check next pair which starts from 3 from relation R. Understood? So you will get what? 1 comma 1 and 1 comma 4. Understood? Okay. Now check next 2 comma 1. In R 1 comma 2 each, 1 comma 1 each. So you will get what? 2 comma 1. Again check 3 comma 1. 3 comma 1. It means you are taking transitive relations. 3 comma 2. Choose first. Not getting. I am telling you again. 3 comma 2 and starts from 2. No. So 4 comma 4. Yes. 4 comma 4. 4 comma 2. 4 comma 3. 4 comma 2. New pair. And second new pair is 4 comma 3. So this is what R of S. Understood? So you are getting what? 1 comma 1, 1 comma 4, 2 comma 1, 3 comma 1. And nil. Nil means no pair of 3 comma 2, right? And then 4 comma 2, right? Understood? If I ask you S of R, so first you will check R. R means 1 comma 1, 1 comma 3. So you will get what? 1 comma 3. Understood? 3 comma 1, 1 comma 3. 3 comma 1, 1 comma 3. 3 comma 3, right? 3 comma 4, 4 comma 4. 4 comma 2, 2 comma 1, 4 comma 1. 4 comma 3. 3 has 2 pair, right? 4 comma 1 already there. 4 comma 2 new pair. Understood? So these you will get from S of R. Understood? This is S of R. R of R means take transitive relation. Understood? 1 comma 1, 1 comma 1. How will you take? Of how will you take? See, 1 comma 1, right? So this is matched. So you will get 1 comma 1. Understood? 3 comma 1, 1 comma 1. So you will get what? Yes. R square means what? R of R. Understood? 3 comma 4. 4 starts from 4 3. You will get 3 3. 3 3. No, see 4 comma 3. So you will get 2 pairs. 4 comma 1, 4 comma 4. So these you will get. Okay. If I ask you what is R cube? R cube means what? R square of R. So first you will take, yes, order matters. You can also write what? Anything. Okay. So first you take what? R square. R square, this is R square, right? Understood? S square means S of S, right? R cube means R of R of R. This slide's finished. Now see this matrix representation. For example, this relation. What is relation? You know how to represent in matrix? You know? Don't know, no problem. How many elements are in A? Three. A is on the row 1, 2, 3, right? And B is on column 1, 2, 3, 4. Huh? Yes. This is A and this is B. Okay. Now see, 1 is related with 2. 1 is related with 2. So first element belongs to A, second element belongs to B. 1 is related with 2 here, right? 1 is related with 3. 1 is related with 4. So whatever they are related, put there 1, otherwise 0. 2 related with 1, 3, 4, and so on. 3, 1, 2, 4, and so on, right? Understood? If both are same set, A, then it will be what? A square matrix. 1, 2, 3. So 1 is related with 1. 1 is related with 2. 1 is related with 3. 2 is related with 2. 3. And 3 is related with 3. This is second. Understood? Okay. You can also draw by what? Digraph. 1 is related with 2. 1 is related with 3. 1 is related with 4. Understood? 2 is related with 1. 2 is related with 3. 2 is related with 4. 3 is related with 1. 3 is related with 2. And 3 is related with 4. Understood? This is matrix representation and this is diagram. Here 1, 2, 3. 1 is related with 1, with 2, with 3. 2 is related with 2 and 3. Understood? Not done with you. Yes, this is called digraph, not diagram. Diagram means directional graph. Okay, with the help of M, you can find also R, right? What is the relation? Wherever you get 1, they are getting pair, right? So 1 1, 1 3, 2 2, 3 1, 3 3, right? Yes. Understood? Yes. Need not to write. I just explained. Okay, right? Now see, whenever in diagonals all ones are there, right? All diagonal elements are 1. They are reflexive. Understood? So whatever question is there, if all diagonal elements are 1, then you can say that is reflexive relation. If at least 1 0 is there, then you can say that is not reflexive. This is not reflexive. You can say and tell. Why? Because diagonally all diagonals are not 1. Understood? 1 1, yes, 1 1 2 2 3 3. Whatever they are, yes. Only see diagonal elements. Understood? For symmetricity, matrix, original matrix and transpose of matrix must be equal to same. For example, 1 0 1 0 1 1 0 0 1. This is a matrix. If you want matrix of relation, if you see the transpose means first row becomes first column, right? You are getting same thing. This is what symmetric relation. Understood? Yes, you can note on this. Done. Done. Okay. For anti-symmetric, when I is not equal to j, all non-diagonal elements are 0. Not all elements are zero. See. Okay, first I tell you transitive. If m of ik is equal to 1 and jk is equal to 1, then mjk ik must be equal to 1. Okay. For example, this is what A12, right? And this is what A23. So what will you check? A13. A1T3 is 1 or not? Not 1. So you cannot say this is transitive, right? For antisymmetric, if ij is equal to 0 or ji is equal to 0, then I for I is not equal to j. Okay? Yes. Note down this. Hello, done? Done? Now see how to take uh, union, intersection, composition of function. See, I explain this directly with example. Okay. This is first matrix, this is second matrix. You have to find what? R1 union R2. So how will you take? Just 1 or 1 is 1, 1 or 0 is 1, right? So R can be represented as what? Understood? So first element corresponding with first element, second with corresponding second element, right? Third with third. 1, 1 is 1, 0, 1, right? So how will you write this? One, 0, 1. Right? You will get this answer. Understood? Here you are doing what? OR operation. You know, no, AND operation in intersection. This is OR operation. You know OR operation? 1 or 1 is 1, 1 or 0 or is 1, right? 0 or 0 is 0. For union, take OR. For intersection, take AND. This is your answer. Understood? See, M R of S. So first of all, you have to write MS R. What is MS? 0 1 0 0 0 1 1 0 1. R is 1 0 1 1 1 0. So always take inside value first. Inside is S. Okay. Yes. Okay. Now see. Just like normal multiplication in matrix, what will you do? You multiply like this, right? So first is multiply with first and or right. First row is multiply with first column, right? Similarly, first row is multiply with second column or zero, right? First row multiply with third column. Are you getting my point? Yes, yes. Where? Second row, first column. Okay. 0 0 1 0 1 1 0, right? Oh, yes. Right? Correct. One. So here 1 and 0 is 0 or 1 or 0, right? Okay. Understood? Similarly, you can find R square, right? Understood? So I think this part you can do this one, right? Can we move further? Now it's very important. What is closure? You know what is closure? Okay. Yes, yes.